Lesson 19 says the graph of a linear equation in two variables is a line, but I think we need to add something to it. So the first video that we're going to do for notes is going to focus on this, what the line represents when we have in a linear equation in two variables. Okay. Oh goodness, here we go already. Okay, so we have a linear equation and we know it's a line. Okay, and I want to add to this title. I want to say graphing by using intercepts. Okay, so the first part of the notes are going to focus on this idea of a line. What does the line mean when we graph everything? And then the second video is going to focus on how we can solve or how we can graph by using the intercepts. So we'll talk more about that in a second. All right, this first one said use x equal to 4 and x equal to negative 4 to find two solutions to the equation x plus 2y equals 6. Plot the points on the coordinate plane and connect the points to make a line. A lot going on here. But basically, I'm going to plug in 4 for x. So I'm going to say, and I'm going to have to do it twice here, so I'll squeeze it in, 4 plus 2y equals 6. And then I'm going to solve that equation. I'm going to subtract 4 from each side of my equal sign. I'm going to have 2y equals 6 minus 4, which is 2. Divide both sides by 2. Y equals 1. So when we used x equals 4, y equals 1, or the point for 1. Now I'll do the same thing now, but this time I'm going to put a negative 4 in here for x. So I'm going to say negative 4 plus 2y equals 6. This time, instead of subtracting 4 from each side, I'm going to add 4. I'm left with 2y equals 10. And then I'll divide both sides by 2. And I'll get y equals 5. So when x equals negative 4, y equals 5, which is the point negative 4, 5. All right, so let's plot these. So if I have 4, remember, left-right movement first, 1, and negative 4, 5. And then I can draw a line through them. Okay. And I didn't do too bad with my line. Okay, now it says identify two other points on the line with integer coordinates, meaning through the grid lines, and verify that they're also solutions to this. Okay, so let's look here. Let's see, right here. That is the point negative 2, 4. So this is the x value, this is the y value. Let's plug it in here. So if I said negative 2 plus 2 times y, which is 4. So I'm going to try to be really neat like this for you so it doesn't get too confusing. I want to know, does that equal 6? Because if it does, if we can plug those x and y values in and it equals 6, then it's a solution. So this is negative 2 plus 8. Does that equal 6? Well, negative 2 plus 8 is 6. So yes, it checks. It works. Let's try one more real quick. Here, 2, 2. And again, this is my x value, this is my y value, and I want to plug it in here. So my x is 2 plus 2 times my y, which is 2. Does that equal 6? 2 plus 2 times 2 is 4. Does that equal 6? Yeah, 6 equals 6. So these 2 points are solutions. These 2 points create the line. They're solutions. That line is representing all the solutions. That's a whole bunch of points. So when x is 1, what does the value of y appear to be? Okay, well, here's 1 on the x-axis. Okay, and it looks like it's somewhere between the 2 and the 3. Maybe it's 2.5, okay, but it could be like 2.47, and how would we know? So let's plug it in. Again, x is 1. I'm using this equation here. 1 plus 2 times y equals 6. Subtract 1 from each side. That's 0. We have 2y equals 6 minus 1. It's a 6 there. Divide both sides by 2. y equals, well, 5 divided by 2 is 2.5, 2.5, which we thought it might be here, okay? So again, when our x value is 1, our y value is 2.5. All right, so when x is negative 3, what's the value of y? All right, so I'm still going to be using this equation right here, so I'll leave it up there. All right, so x, negative 3 plus 2 times y equals 6. So all I did is I took this right here and I plugged into it for x. Now, solving like we've been doing, I'm going to add 3 to both sides. I have 2y equals 9, and I divide both sides by 2. And 2 divided by 2 is 1y. If you go 9 divided by 2 and divide that out, that would be 4.5. So, sorry, I never even finished this up here. That was my x value, that was my y value. Here, if my x value is negative 3, my y value is 4.5. Oh, I'm sorry. So let's look at the line here. Negative 3, 4.5. Here's negative 3. Looky there. It's halfway between the 4 and the 5, so it could be 4.5 for sure. It is 4.5. All right, so is the point 3, 2 on the line? Well, let's look. Left, right movement first. Here's 3, and if I go up 2, it's right here. Is that on the line? Simple answer, no. So is it a solution? I hope by now you guys are starting to realize that any point on the line is a solution. Since this isn't on the line, it's not a solution. And we can prove that algebraically by just plugging in this x value and this y value right here, okay? So instead of saying x, I'm going to say 3 plus 2 times y, which is 2. Does that equal 6? Well, 2 times 2 is 4. Does 3 plus 4 equal 6? No. Okay, and that's why it's not a solution. So you can pick any point on this line as a solution, and any point not on the line is not going to be a solution. All right, let's do one more of those real quick here. I'm going to move pretty fast through these because we're basically doing the same thing, okay? So this time we have x equal to 3 and x equal to negative 3 to find two solutions to this. So I'm going to be plugging in those x values here. 2 times 3 plus 3y equals 12. And I'm going to solve this. That's 6 plus 3y equals 12. Subtract 6 from both sides. 3y equals 6. Divide both sides by 3. Wow. See, I said I'm going fast. I'm going to get sloppy here. And that's 2. So y equals 2. So when my x is a 3, my y is a 2. All right. And now I want to plug in negative 3. So right here, 2 times negative 3 plus 3 times y equals 12. 2 times 3, negative 3 is mean negative 6. Plus 6 plus 6. 3y equals 18. Divide both sides by 3. Y equals 18 divided by 3, which is 6. So in this case, when I input a negative 3 for x, I get an output, my y of 6. So negative 3, 6. Okay, and again, we draw a nice long line because, because I want to be able to find points, right? Without messing things up. All right. Okay, so identify two other points in the line. You know what? I'm just going to do one because you guys get the idea. So let's maybe look at the point 0, 4. This is my x value, this is my y value, and I'm going to plug it in. And I'm going to go 2 times x, which is 0, plus 3 times y, which is 4. Does that equal 12? Well, that's 0. And 3 times 4 is 12. So yes, 12 equals 12. It checks. Okay? All right. And I can do that for any point on the line. So when x equals 2, what is the value of y? So again, I'm using this equation here, and I'm going to plug 2 in for x. And I'm going to go 2 times 2 plus 3 times y. I don't know why I put parentheses in there, sorry. Equals 12. So we get 4 plus 3y equals 12. Now, if you need a review of solving equations, that's what we're doing a lot right now, right? Solving for the y term, I got to get rid of the 4 first. So I'm going to subtract 4 from each side. I get 3y equals 8. And then I divide both sides by 3. And y is equal to 8/3, which is 2 2/3, which is approximately equal to 2.67. So if you wanted to, write the point, we're going about 2/3 up. So let's look. Okay, so the point 2 2/3, if we look here, here's 2. And if we go up, oh, look at, yep, does look like it's kind of going up 2/3. Again, that's why we need that equation, because you can't really tell from the graph if that is 2 2/3 or 2 3/4. Anyway, moving on. Is the point 8, -3 on the line? Well, here's 8, and -3 would be right here. No. So, is it a solution? My guess, not my guess, we know it's no, okay? Only the numbers on the line are solutions. But if I wanted to plug it in real quick, again, this is x and this is y, I would say 2 times 8 plus 3 times a -3, does that equal 12? 2 times 8 is 16, 3 times a -3 is a -9, does that equal 12? Well, 16 plus a -9 is 7, that does not equal 12, okay? So just to kind of wrap things up here real quick, it says based on your work in exercises 1 and 2, what conclusions can you draw? Well, I'm going to say this. The points on a line are the solutions to the equation, okay? The points on the line, those are the solutions. Based on your work in these ones we've done, will a point that is not a solution to a linear equation be a point on the graph of a linear equation? If it's not a solution, is it going to be on the graph? Is it going to be on the line? Oh, no. Only the points on the line are solutions. And finally, based on your work, oh, sorry, that should be exercises 1 through 2 there. What conclusions can you draw about the graph of a linear equation? We're going to say the graph of a linear equation, maybe we are, is a line. Okay? So any linear equation is going to be a line. We know it's linear. The variable terms are to the first power. Only the points on that line, and it's made of a bunch of little points, are solutions. Any other point off that line is not going to be a solution to that linear equation.